Hello everybody, welcome back to another video. Today we're going to be looking at a very interesting problem, which is the natural logarithm of -1. Usually when we have the graph of natural log, we know that it can't go to the left of the y-axis because it's not defined for all of these negative numbers. But if we think in the complex plane, maybe there is an answer. That's what we're going to be looking at today. So let's get right into it. First off, I'm going to be using a main equation for today, which is Euler's formula. If you can recall, it's e to the ix equals cosine of x plus I sine of x, just like that. There's an entire proof on this, and it's quite beautiful, actually. But in summary, you just have e, which is Euler's number, 2.7182818, and goes on and on. To the power of I, the imaginary number, square root of -1, of course, times x in the exponent is equal to cosine, of course that function appears everywhere, and plus I sine of x. So this is in the form of a plus bi, which is really nice because then we get a real and imaginary part. So using this formula, let's see if we can draw a very interesting conclusion. Both cosine and sine are built around the period of pi. If we look at the graph of cosine, if I can draw it real quick, like this, everything on cosine is built all around pi, just like this. Its maximum, its minimum, everything is on pi. And if we look at sine of x, we have just like this. Oh, that's a bad graph. But if we look at sine, more like this. Sine is more like this. At pi and 2 pi, it has its zeros as well. So we know that cosine and sine are built around the concept of pi. So what happens if we plug in pi for x in the exponent? What happens? E to the I pi is indeed equal to cosine of pi plus I sine of pi. And what does this mean? E to the I pi, that has 2.718, that Euler's number, and the imaginary number, square root of -1, times pi, all three very cool numbers in all mathematics. So I'll write this in red because I think it deserves something more than just white. Then is equal to cosine of pi, that is indeed -1, plus I sine pi. Sine of pi is indeed 0, so we get plus 0i, which is pretty cool actually, meaning our imaginary number comes out. So what does that mean? That means we have no more imaginary number on the right side of the equation, and that leaves us with e to the power of something imaginary times pi is equal to a real number, -1. Quite fascinating if you look at it. So another way to write this, which is just for fun, I like to do it 2.71828 to the power of the square root of -1 times 3.14159 is equal to -1. So indeed, it's a really cool property, and it's known as one of the most beautiful equations in mathematics. E to the I pi is indeed equal to -1. So from this conclusion, our initial question was, what is the natural logarithm of -1? We see if we take natural log on both sides, let's do that real quick. Move this to the right here. If I take natural log on here and natural log here, natural log and e cancel, which means I pi is equal to the natural logarithm of -1. So that answers the question. Now, what's the natural logarithm of -1? I pi, which is a pretty cool definition, which means that we can take our original natural logarithm function and extend it beyond just that, just x is greater than equal to 0, because that's the original domain we defined. Now if we plug in a negative number, we get I pi, introducing our complex plane. So we can take this a step further. Let's look for a second. Something cool we can draw from here is that I is indeed equal to the natural logarithm of -1 over pi, which is a really, really interesting definition. And you can do all sorts of things with that. You can plug it into your most favorite equations using I, and it looks pretty strange to see a pi there, but it's indeed true. Or alternatively, if you want to, you can rearrange the equation just using algebra rules. Oops, like that. pi is equal to the natural logarithm of -1 over I. Pretty crazy when you think about it. Like, you're saying that's equal to the circumference over diameter of a circle? Yeah, it is. It's pretty cool. And then if we look at other definitions of pi, we can say that's equal. I can do a separate video on this, but indeed, this number right here, which comes from the Gaussian, I believe, yeah, the Gaussian integral. If you take this quantity and square it, this is equal to pi. So, well, I can do a whole separate video on this because it's a very cool fact. So you can indeed say integral from -infinity to +infinity of e to the -x squared dx squared is equal to the natural logarithm of -1 over I, which is equal to pi, and you can have as many definitions as you want. It's pretty cool. So that concludes our video and answers the essential question, what's the natural logarithm of -1? The answer is I pi. Let me know if you guys enjoyed this video and if you guys want to see more. Thanks, guys. See ya.